So I'm here to talk to you about model-based systems engineering and how we use it to provide insight into the systems ergonomics issues when you're introducing new technology in rail systems. So as Paul said, I'm an Associate Research Fellow at the University of Wollongong. I'm not from the Sunshine Coast, so the first one not from the Sunshine Coast, but from the beautiful Illawarra Coast, which is about an hour south of Sydney. So I work at the Smart Infrastructure Facility and we do simulation and modelling. My expertise is in systems engineering, organisational systems and soft factors modelling, model-based systems engineering more recently, and also I've done research projects in the past looking at human reliability assessment in the military domains. So my experiences are, if you can probably tell from the English accent again, is that I'm from Loughborough University, which is in the UK, previously working at the Systems Engineering Innovation Centre, and before that working in defence with BAE Systems. Okay, so let's set the scene on what the problem is in the rail industry at the moment. So if we look at the large colourful chart on the right, we see a really large mountain that we've got to scale here. And what we've got is, over the next few years, there's vast investment in the rail industry, and we're looking at getting up to over $7 billion of investment of new technology by the year 2023. And if we look at the graph on the bottom left, we can see that the supply of the different engineers, in fact, for many different industries, the technical engineers are just simply not there, is just going to get worse as you need more and more construction and other engineers in order to be able to fulfill the demands. So what we're looking at is how's the organisational system going to position itself so that it can be able to use these new technologies and transition smoothly, get the right people with the right skills. Okay, so organisational system evolution. What are the key challenges here? So we start with looking at the organisational structures and the human resources. How are these going to change in the future as you bring in these new technologies? What about the complexity and synchronisation issues? Here you've got many different organisations from system integrators, vendors, supply chain systems and systems issues, as well as many different technologies that are coming in on top of each other with different timescales. So how do we synchronise our organisation to be able to deal with all these sort of little step changes at the same time? How do we make timely decisions? So let's take, for example, introduction of new train driving systems. If you have to ensure that they've got the correct competencies, obviously you don't want to be training people after you've deployed your system because you haven't got the skills that you need, but you also cannot train them too early. They say the rule of thumb is somewhere between 6 and 9 months before is the optimum training because they tend to forget if you train too early. So how do you make sure that you're making timely decisions based on your system deployment? Because system deployment doesn't always, as many people working on large systems will know, it doesn't always get deployed when you initially planned it. And so you have to work on a sliding scale of time to meet your competencies from those. And how do we plan for smooth transition? So how do we say, we've got a bit of a little maze here. How do we ensure that we're not going down the dead ends? How do we ensure we're going in the right directions? Because in the rail industry, it doesn't stop. It's 24 hours almost operational. We can't stop the system and install a brand new system totally in one go. And ultimately, we're looking at the organisational capability. What do we need to have in the future with our organisations in terms of skills, competency, knowledge and experience? And ultimately, altogether, we're looking at being able to look forwards to predict and de-risk changes. So what are the systems ergonomics issues? So in the 2014 Applied Ergonomics Journal, they had a special issue that was all about systems ergonomics. And the late Wilson sought to try and bring the human factors and ergonomists together to have an understanding of how systems ergonomics is impacting on the field. At the time, it was really a convergence between systems engineering and human factors ergonomics. So the ergonomists were actually always working on systems, and the systems engineers always had human systems integration within it. So at the time, it was really a convergence of these two fields. So the three main areas that Paul has also alluded to are looking at a systems focus. So how do we break it down into subsystems? How do we look at various different levels of decomposition and abstraction? We also look at interactions between the different areas. How do we manage those both internally and external to your organisational system? Also the context, so what's the environment around your system, and what are the different sort of sets of behaviours or the characteristics of different contexts that are going to affect the behaviours that you're looking for. We also look at emergence, so we're looking at both good and bad emergence. So how do you harness? So they say, the sum is greater than the parts. How do you actually harness that and ensure you're going to get that good emergence? But at the same time, how are you going to de-risk your process to try and identify what the bad emergence or the things you don't know are yet because your design is not mature enough? It's also a holistic process, so we need to look at the whole. We look at small parts of it, but we build it up together. And finally, as well, it's about embedding. So we have to make sure that our human factors and ergonomics activities are part of the overall systems engineering experience activities. So what is model-based systems engineering? Is there anybody who knows what model-based systems engineering is? One at the back? Two? Okay, so let me just go through this very quickly. So imagine in the 1970s when you had a large engineering firm. At the time, it wouldn't be uncommon to find really large drafts tables, draftspeople's tables, and all your engineering designs would have been on paper, massive big plots of paper. And as the third industrial revolution came in around the 70s and 80s, a lot of these became like CAD models. They're now available as digital models. And so what model-based systems engineering seeks to do is create the systems engineering artifacts as models that can work with the technical engineering artifacts at the same time. So you'd have things like, how do you model requirements so that you can provide traceability and reuse within the existing technical systems that you're developing too. And it looks at it from all the way through the system's life cycle, all the way from the conceptual into the development and into operations. So what does model-based systems engineering do? Well, we're moving from essentially looking at many different people working on different parts of systems engineering. Previously, you had like the requirements engineering management, you might have had the human factors engineer, you may have had the validation engineers, the design engineers. What this seeks to do is make it so that we can move towards one single database or one area that all the information is stored in. So therefore, you get a single source of truth, you have improved integration of all the different artifacts and consistency because you're using the same elements. It reduces error, ambiguity, and redundant work. We also look at viewpoints and separations of concerns. So you wouldn't want to be able to see everything in the database that's not applicable to you. So you need to look at providing different viewpoints to be able to provide a constrained set of information that you can access and read. And finally, it's about reducing this developmental risk. So, finally, the work that the University of Wollongong has been doing is looking at the organisational capability maturity model. It's essentially looking at holistic models for the impact of new technologies in organisations. It's developed at our university with funding from the Australasian Centre for Rail Innovation. It's been developed using model-based systems engineering technologies, UAF and SysML in a piece of software called Magic Draw, which helps us to integrate it all together. And at the moment, we've tailored it for Transport New South Wales and Queensland Rail. What is the unified architecture framework? Well, we have to have some kind of framework in order to slot all these different viewpoints into so that we can integrate them. So much like the cognitive work assessment, which also has a framework. This also has a similar kind of framework looking at going from like the strategic levels, operational levels, down through to the different levels of decomposition. It was developed by the Object Modelling Group in 2017, and you may know them because they've also hold the standards for UML and SysML. The personnel view was built up from what was the human views that came out around 2008 in both MODAF and DODAF. And so I've just highlighted the personnel view across here. Behind this architecture framework is actually a profile, and the profile holds all the different building blocks, the items, the things that you're going to make or instantiate objects out of. And so what happens is that if you look at different cells within this framework, they'll be using the different building blocks from that profile that may be in one or more of the other boxes. So what's our development approach? Well, what we were looking at is creating the organisational models of the current and existing state and looking at what the organisational models of the future state would be. And we couldn't really model everything. It's like, how long is a piece of string? So we looked at various different technology introductions and were guided by our ACRI participants. And therefore, we had to look at what were the key processes that we might want to look at, what are the tasks and how are the humans involved. And finally, we looked at a set of different human factors concerns and how could you create the models within that unified architecture framework. So just thinking quickly about enterprise system evolution. So we very much looked at Rouse's view of the enterprise system, which is a socio-technical combination of both the technical systems and one or more organisational systems too. So if we look on the left, we were considering one or more different technologies coming in with different timescales. What we're also looking at is how do we move our enterprise to be able to be flexible to deliver the capability that we need in the future. So as we know, we have human factors integration. We need to be able to look at all the interactions between the technical and the organisational parts through time. And through this, we have various databases of information. And these are the types of things you may have inside. So you might be, say, starting from the technical systems, you might look at the level of the design maturity you've got, which may feed into the conceptual designs, and the organisational human factors engineers might be looking at the conceptual designs, applying their human factors assessments to make recommendations on what the future design should look like. And it will go back and forth between all the different databases. So ultimately, what we're looking at is, as it goes back and forth, it's looking at building this sort of spiral where it's taking information, using information, and improving it, and so on and so forth as you go down the screen and evolves. But also, your enterprise is not it's not a separate independent entity. It exists within an environment and it has to flex as well to exist in a competitive market. So we look at the macro environmental factors like the PESEL, political, environmental, social, technical, legislative and environmental factors. We look at the markets and other organisations, what's going on, supply chains and mergers, and the systems of systems, not just the organisational ones, but the technical systems of systems as well. What improvement initiatives are going on internally, and what's the workforce supply like? Oh, how are we doing for time? We're good. Okay, so this is the scope of the UOW's approach. I'm not going to have time to be able to tell you about all these different parts of the models that we've created, but what you can see here is that we started with a set of technologies, and we derived these from the Smart Rail route map, which was an industry-wide activity that came out at the end of last year that looked at both the short-term and long-term technologies that would be coming in the next 30-year horizon for Australia. And we filtered these down based on our ACRI participant needs. After that, we looked at a number of different processes, which were, pardon the pun, the vehicle for being able to assess how the humans were involved. And then we created these user portals or viewpoints for different types of users of the tool that we were creating to be able to see the information that they needed to. So what actually were the human factors concerns that we looked at? So, I mean, there could be many. How many methods were there? 16 different methods or something. But we whittled these down to a set of 8 that were filtered by our ACRI participants of most interest. So we looked at the competency. What are the skills, experience, knowledge, and attitude that are involved in order to be able to use these new systems? Therefore, what training is required to get you from your current state skills to your future skills? What's the role allocation? So how are people involved and how will they be involved in the future in the tasks? What are the workload and situational awareness implications and how can these inform the design of the future systems? We looked at safety assurance and being able to do hazard analyses on both the technical as well as the human or task-based analyses. We also looked at the impact of human factors in cybersecurity, as well as how do we look at organisational culture? How do we model the values that are going to be impacting on the behaviours that we expect in the future? But all of these are not disparate, they're actually interacting together. And oops, I'll just go back. So I haven't got time to do all 4 of these, so I might just do a couple. Okay, so the first one we looked at was the role structure here. Obviously, a role is not a job or a job title. It is like an actor. So it's how are you involved in the task. And for this, we could use whichever method that you want to, but for the purposes of our tool, we gave them a demonstration using the VASC analysis, which is involves looking at each task and identifying who the different roles would be and how they're involved. So the responsible role is the people who are doing the task, accountable are the ones who are controlling the role, those who are ultimately responsible, ultimately accountable for that. We looked at those who are supporting the responsible role, those who are consulted, and finally those who are informed of either the information coming out or those who would be needing to know that task is finished. And so what we could do is we could then model the roles on top of the SysML diagrams that we'd created, or we could allocate them directly via matrix. And what's new that we've created is within Magic Draw, we've created these diagramming dependencies, so we've extended some of the profiles in UAF to be able to automatically generate these kind of diagrams. So rather than seeing it in a tabular form, we can then see it in a slightly better visual manner. Okay, and so then we looked at the competency. So as I said, skills, knowledge, experience, and attitude. And we created a vast library of competencies. And these came from the AQF frameworks. They also came from any competency management frameworks within the organisations. And what we had here, this is a swim lane activity diagram in SysML. In this case, we're looking at the possession protection officer who's looking at a local protection authority. It's a type of track work. And we looked at the introduction of tablets. And so what you could do is you could identify for a given role, performing a given task, what kind of competencies would be required. And we could do that in the pre and the post and any different levels of transition in between and do a gap analysis between the two to see where you've got to get to, what are the competency gaps, and therefore what kind of training you require. And as you can see, that then feeds into the other portals. I think I probably don't have time to do the workload and cybersecurity, sadly. And so what we end up with is a set of integrated models. They're using the same processes, they're using the same system structures underlying them. And so this is a meta model that shows you how we've extended some of the UAF profiles to be able to look at, say, I can't point to this. You can see the competencies on the upper left, and you can see how those will break down into skills, knowledge, attitudes, and experience. At the same time, you can see how the organisational cultural values may feed into as a type of attitude, because your cultural values will affect how likely you are to behave in the way that you're expected to, which is the competency that you're going to be doing. It looks at the organisation's roles, posts, and individuals. And you can see quite easily, this is simplified, by the way, because it would be unviewable. It would be kind of like Gemma's initial one with all the hundreds of lines between it. So this is a simplified version just to show you a little bit of a flavour of how all the different interactions are being dealt with within our model. Okay, and so the conclusions, well, so far we validated with the two stakeholder organisations. We had reviews every 4 to 6 months with the different participants to get information, get feedback on how the portals were, to see if they had any improvements or any ideas for information that would make it better. We're looking at now supporting the other active participants who didn't have it tailored, for them to be able to use OCMM or parts of OCMM to tailor to their human factors activities that they use. We're also looking at doing a retrospective analysis on the introduction of the advanced train protection systems. So they've just started to introduce it within one of the the rail operators. So we're looking to see what the problems were and whether we can unpick some of the complexity by working sort of backwards with the models. And finally, we're looking at how to automatically import and integrate with their existing software systems and other linkages to, say, like the rail standards. All right, thank you.